resolution survey. Itu kapal for one project. I was on that kapal for 2,5 bulan. So even my whole Ramadan on that ship. Saya sendiri buka puasa and then do everything by myself. And even you find the tanda-tanda Lailatul Qadar, and then the pagi after that the sunrise, like wow, this is amazing. Itu semua laut is just flat, nggak ada bergerak, something like that. Anyway, so I worked 21 years. I look after navigation system for the ship and the submarine. Sonar system itu untuk bikin peta di dasar laut. Radar system untuk cari if there's another ship in the area. Kalau hujan deras, LiDAR pakai laser untuk sama ranging. Underwater communication system itu communication system untuk submarine ke kapal. So kan nggak bisa pakai RF, nggak bisa pakai wireless kan di bawah laut. Gelombang RF diambil from the water. So we pakai acoustic. Acoustic seperti suara ikan paus, the whale. And then so that's how we base the underwater communication system. And then data acquisition system kita untuk bikin the peta dasar laut, we have to record the data. We pakai sonar, and then we go and record the data. In Australia, I'm a certified drone pilot. So kalau mau bikin business di Australia, you can ask me if you need to fly drone. Aku. And then I used to build my drone. Soalnya di tahun 2011, sebelum drone menjadi gampang banget, bisa beli aja and then langsung terbang, kita harus rakit dari nol. So that was very hard. It was 2011, long time ago. And then GE, dia ada namanya Predix. Predix ini salah satu industrial IoT platform yang dibuat by GE, made by GE, untuk dipakai di manufacturing sama di maintaining machines, untuk predictive maintenance. So IoT ini dia di dalamnya ada banyak udah machine learning profilnya for for train engine sama PLTU, the steam turbine di dalam PLTU. So that's the kind of stuff. So I put this slide. So then I will talk so fast, but then if you kalian mau, you can just take a photo and then you can open the QR code and you can see the project tentang what these projects are about, what I did before. So for example, you have the survey ship, it will show you the video of the ship doing survey. Ini yang ada L3, that is the one for James Cameron yang dia he went to the bottom of the sea. Nanti I'll show you the video. Now if you see di atas the L3 ada Arduino. Nah ini Arduino dia pakai di dalam project James Cameron, itu udah turun 12.000 meter. So itu Arduino, ada 3 Arduino di dunia yang udah ke dalam dasar laut, all the way to the bottom of the sea, and that was in that project. So kalau orang bilang, Arduino, apa aja Arduino, they used it. This is an industrial application for Arduino. So, and then you see the small robot yang ada flag Australian. That was autonomous robot. I built the chassis and put all the sensors together. Ada LiDAR, ada mesh networking, and all the communication that we use in normal IoT platform protocols. It's running in there. So that one, it's seperti soldiers yang mau buka satu daerah gitu. So dia akan jalan sendiri tanpa remote control, and then they will mapping the area, bikin SLAM, so simultaneous location and mapping. And then kalau dia ketemu ada orang atau satu object of interest, dia akan kasih tahu kita, hey, I found something. And then when we say, okay, what's action, kita bisa say, okay, take it out. Nanti ada satu lagi robot sendiri tanpa awak will come and then shine the laser pointer on that on the target. So it's kind of scary, but because we're just watching it happen, the robot is just doing his thing by himself, no remote control. But that is the future of autonomous. I was already playing that technology in tahun 2010. So 2010 udah ada, autonomous machines using image recognition and laser rangefinding. And also here we have some more. So if you see the sonar USV, so USV, it means unmanned surface vehicle. So ini is a drone for the water, for the air. Nah, di ini udah pasang sonar. So we don't have to pay berapa puluh ribu dollar untuk sewa boat anymore. We can just buy the small boat and put the sonar, and we can bikin peta laut juga. So itu from technology, itu cutting cost banget in industry. So that's why I talk about the machine learning, the IoT. Ujung-ujungnya untuk apa? Untuk finance gain, make money or save money. That's the only two things. Soalnya who will pay for the project kan? It's from the accounting, from the finance. If you don't have a business model, it's not going to happen. If you look at the other one in Sydney Harbour, I was just doing the photogrammetry with the drone. So if you can see the rainbow data, itu data dari sonar, and then gabung sama data dari drone. So kita bisa lihat ini aplikasinya untuk for the kabel fiber optic. So for that project, saya lagi dari New Zealand ke Sydney, itu aku bolak-balik 3 kali in 2,5 bulan. And then itu untuk dia mau pasang kabel fiber optik untuk naikin bandwidth, kapasitas internet di antara the connection speed between the two countries. So using this data, kita bisa lihat mapping, ini kabelnya bisa lewat dari from under the sea, langsung ke the beach, and then langsung bisa naik. So for the planning, for the orang yang lagi cost analysis, yang lagi planning for the material, they can get a more accurate idea and more accurate estimate for the cost. And then here again, this is the same for the so here I'm going to play a video. Now the main QR code on the underneath the YouTube link, if you can click, if you click that, it will open a YouTube video of the video I will show you. So this was the one for James Cameron, yang the director of the movie Avatar. So itu 2011 ada perusahaan datang ke company kita and they said, hey, can we use your underwater communication system? I said, what for? It's top secret. So in tahun 2011 kita ada NDA, nggak bisa ngomong. Nah, tahun 2012 itu ternyata James Cameron pakai itu di submarine-nya untuk turun in the bottom of the sea. So dia bisa menjadi the third person ever to attempt that. So I'll try the video, but if you take a photo of that and then see if you can see the same video with me. Yeah. So if you can see on the di atas submarine itu ada dua small cylinders sticking up. That's what my company provided to James Cameron for this event. So itu ada primary communication acoustic modem and ada backup communication acoustic modem. So when he had that in his system, he could do the world's deepest tweet. Dia tweet dari bawah itu, and then dari atas in the kapal in the ship, his wife, he can call him and say, and hey, hello, how are you, darling? Are you okay? Yeah. So let's see. So basically, this is who I am again. It's a lot of stuff from hard skill. I just wanted to, Sonia, what have you done? So if I can just put, I have a mind map too, but I just put it on the screen. It's a lot of stuff, but yeah. I mean, 21 years is a lot of things to do, kan? You can cover a lot of things. So who is Zulu? Zulu sebenarnya kita it's Indonesian company, in local company. I just joined in tahun 2018 when Gojek did the investment ke kita, and then we have selling helmet yang udah ada Bluetooth-nya. So I think we were the first Indonesian company to sell Bluetooth helmet from a long time ago. I know you can buy the Bluetooth headset from Tokped and then just attach. It's a similar thing. So we manufacture the helmet. We did design the helmet, and we make gloves, jackets, and other things. And then also we, at the moment, kita lagi incubating startup lagi, breezejakarta.com. So it for air quality monitoring system. Soalnya when we look at the local air quality monitoring, it is only PM10, bukan PM2.5. Nah, PM2.5 itu particulate yang pengaruh ke paru-paru kita. So we need to know how much is in the air. So kita tahu harus pakai masker. Nah, tapi sekarang kan udah ada virus, so kita pakai masker anyway. So we okay. And then even now, if you lihat di luar, the sky is blue, so the pollution is already turned. So that's what we've done. And then these are just the links to my pages. So we have two business models at the moment. We have B2C, business to consumer, which is on the Lazada. So you see here the helmet that we make. This is our second generation Bluetooth helmet. Ini semua electronic design in Indonesia and built in Indonesia. And so it's going to be the first Indonesian Bluetooth helmet built here. So we already have the patent for it as well. It's a all-in-one design, and hopefully we want to sell it for an Indonesian price. Bukan seperti ada helm Sena yang kompetitor. Di luar negeri, dia jualan $360 for Bluetooth helmet. Now, if I can sell this for $1 juta, it's okay, right? So it makes the technology lebih affordable, lebih accessible to the people sama dengan Gojek to do the helmet yang baru, design baru, jacket and helmet. So ada dua tipe jacket, satu yang anti air and one is anti panas. And then kita harus produksi jaketnya juga. So in 6 bulan, we had to make 1,2 juta jacket. And then sekarang udah sisanya 10.000 dari 1,2 juta. And then dari antara 1,2 juta itu ada 7.000 yang reject. So our quality management is a bit okay. So then we do the design and production for a GoFood bag. Nanti ada GoFood bag versi kedua yang ada panel surya. So driver bisa charging mereka. So yeah, this agak lama tentang saya and what I do, but I'll get to the the good stuff. So this is Zulu. So we can see quickly the design, Bluetooth helmet, the different kind of logo, and the production of the helmets in the factory. And then with the jackets, we did the jacket design, we managed the manufacturing process, and then we even do the selling. And every single jacket and helmet ada RFID-nya, ada smart barcode. So kita bisa tracking, semuanya ada serial number. So pas kejual ke driver, dia itu udah assign ke driver dia. And itu was a process of digital transformation of Gojek's inventory system. Nanti I will show you. So this is the GoFood bag from dari sketch gitu, schematic, menjadi real. And nanti it's out, you should see it on the street soon. So ini kita do market research, kita ke pangkalan Gojek and ask them, what do you want in the bag? And then from dari feedback mereka, we make for them. So this is what we did for the Gojek project. Soalnya I told Gojek, you need to use RFID. Soalnya kalau kuantitas 1,2 juta in 6 bulan itu gila kalau mau inbounding ke warehouse. Kalau tiap hari ada 8.000 datang ke warehouse, itu kalau hitung manual, it will too much time. So kita harus pakai teknologi untuk bantu kita. So ini kita rakit. I designed the alat, which is a RFID reader and barcode printer. So then they can use in the jacket and the helmet factory. So, okay, here we go. This is the main, everybody's waiting for this one. How and why IoT is needed for machine learning. So if you can look at this, I know this kuno, silly cartoon, tapi it's kind of true, you know. So if you look, this one guy is complaining, oh, you know, your fitness band is telling me it's not working, something wrong with it. But then the analytics is saying, oh, jantung saya akan stop in 5 seconds, 5, 4, 3, 2, 1. Now, that means, that means the IoT device is the Fitbit or the Garmin or apa aja, Xiaomi band. Nah, dia rekam data all the time, data acquisition. Nah, abis itu kita ada profile for the machine learning, profile of human condition. So you could do this, but would you want to buy this value? Like, do I really want to know when I'm going to die? Maybe some people do, some people don't. But yeah, at the bottom there, I put a disclaimer. Yeah, only the one up there knows when you're going to go. So, but in the meantime, you just try and enjoy what you have. So I think this is a simple way to show you why IoT is important, why machine learning is important in life, in business, and everything else. So now, we already have the data. Now what we do with the data, we analyze the data. So we have, these are the different steps of, if we have data, we can do this. We can do descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive. Nah, descriptive is just hanya seperti dashboard mobil gitu, yang kalau lampu zen on, tiktok, that's descriptive. Okay, my analytics itu when your mobil ada your mobil ada lampu oli nyala. It's like, hey, your oil is low, so you got to do something about it. So that's a diagnostic. Now, predictive itu is like the system will tell you, hey, if you keep going like this, I'm gonna break. Nanti I'll show you the example. Now, prescriptive is dia bisa tell you how to run the machine before you run the machine, and it tells you the right way to run the machine, and it will tell you if you're running the machine the wrong way. So here we go. Here's another video. So I'm gonna play another video. This is from GE using the Predix platform. So they have the IoT in every single PLTU, like the steam turbine, to monitor all of the data. So they collect all of this data, and then they have the machine learning profile of each operating turbine. So they don't use the same profile on every turbine. So each turbine has its own operating, even if it's exactly the same hardware, there is some variance due to mechanical or environmental factor yang affected. So the profile harus learned. You cannot just maksa this one profile, operating profile untuk semua. and then you will have some issues. Now with machine learning, you will find that proper upper limit and lower limit to stay within. So anyone that, if this fails, then you can see the video. I'll play now.
Operator, a change in my mission is causing damage to my HP turbine rotor.
Okay, Twin, help me understand the problem. What's your operating profile?
In past 6 months, my number of cold starts is 4, my number of warm starts is 8, my number of hot starts is 39. The number of start-stop cycles has increased by 27.5%.
Twin, tell me about your rotor damage.
My damage rate has increased by 4.0 times over last 6 months. If this continues, I would lose 69.9% of my useful life.
Twin, give me options for mitigating that rotor damage.
Based on weather forecasts, historical data, fuel cost, electricity pricing, and my present condition, I have 2 options for you to optimize operations. Option 1 is to manually slow down my startup ramp rate so that you can reduce the wear on my rotor. Option 2 is to download the OpFlex app and apply stress controls to minimize wear and reduce fuel consumption too.
Twin, give me the factors you used to calculate option 2.
I used my past 15 years of historical data, fleet learning from 125 other D11 steam turbines like me, and 58,965 simulation runs to get this recommendation. I'm 95% confident of my assumptions.
Twin, I need a financial perspective. Tell me about the numbers.
The numbers look good. We can reduce stress by 25%, which brings the damage rate back to normal range. Startup fuel cost will go down by 40% and startup time will be cut by 50%. You will also avoid $12 million by preventing an unplanned outage.
Twin, okay. I select option 2. Let's do it.
I'm initiating option 2, which is Flex Start. Thank you.
So you can see in this example, the machine can become total, yeah. So I just show you. So these are some of the machine learning algorithms available, and then I'll get back to the video. So don't worry, I'm just jumping between the video and then some theory. So we have so many kinds of machine learning algorithms. You need to know which one to use for your application. So these is what is available. You have unsupervised learning and supervised learning, and all of the different ones. Now, I won't go into all of these in detail, but I'll just show you high level what it is. So this is a simplified landscape. So chatbots, the ones that you have in every single app now, or web page, and a chatbot say, "Hey, hello, can I help you?" That is a very what you call narrow AI. It's very small. It just does basic, boring stuff just to interface with people. But it's using NLP. So that is one algorithm. You have the personal assistants like Siri, Alexa, Bixby. They use NLP, natural language processing, and speech processing. So it's audio processing. So they are taking. So your phone is actually an IoT device. It is the first IoT device. Maybe it's mass. It's already like global. How many billions of mobile phone IoT devices on the planet, and how much data it's going to their machine learning algorithms. So that's why Xiaomi and Huawei, they can have all of that fancy AI filtering because everyone is using their hardware is actually helping them train their machine learning algorithm to become more accurate. So You have automated insights, machine learning, natural processing, autopilot by Tesla. That is very interesting. The car that can drive by itself using the laser scanners and data from the internet and itself, so it can navigate the environment. So it's using machine learning. So it needs to know how to act like a car. How can a car move from here to there, and when should I turn left or turn right, like, and what to do as a, so otherwise if it's just suddenly jumps in front of and accelerate, it becomes a dangerous thing on the street. Everybody knows Deep Dream, the machine learning, and Watson now, the IBM platform, and Einstein is a different one. So they're the ones at Deep Dream, they're deep AI, where you need a big supercomputer to run this because you're doing so many calculations at once, and everything is in parallel. Whereas with the chatbot, it's just one-on-one. Yes, no, hello, yes, yes, reply, respond. Whereas deep AI, there's so many millions of data being put in, and they want to find the best fit. AI, machine learning is a part of AI, and AI it's not like a human brain that can do everything. Like, it's not as smart as a human. It's only as smart or as productive as the orang yang program it, as the orang that put the profile inside it. So everybody, before, long time ago, before, it was to be about big data, big data this, big data that, or IoT this, IoT that. It's a sales term that sometimes hiding bikin nggak jelas yang the actual application and how to implement it. So all of these algorithms, they're all mathematical. So anyone with a maths background or even a computer science background, they can understand the flow. It's just step by step, next step, next step, next step. Anyway, so back to this is, I'm just looking at the video before and what is happening in this video. So if you look at the first dashboard, this dashboard that showed us the engine was telling me, was talking to me, it was using NLP, right? It was doing machine learning as well. But at this moment, he's only showing us descriptive and diagnostic analytics. He's just showing us, this is what my operation day to day. Today I did this, that's it. That's the, like, I just read the data from the sensor, not much processing, and it's display for the human. And then for the diagnostic analytics, you can see that the start-stop cycle has increased by 27%. So that one, it's already, there's some kind of profile running on there to calculate that. So the next one is talking about the diagnostic and moving into predictive analytics. Now the machine can tell you, hey, Pa, you better fix me, otherwise I'm gonna break. And my life just went from 100% or 10 years to, I just lost 70% of my life. So I only gonna have like 3 years left of operation. So Pa, can you please fix me up? So using the machine learning doesn't happen just like that. No, kita butuh so much data of the operation of this engine, so many hours, so many years. Nanti you'll see. And then from the predictive analytics, this is what's likely to happen. Prescriptive, ini yang saya bilang tadi, that the machine bisa kasih, he can tell us advice, Pak, kita harus begini, ini ada opsinya. So we don't have to look for the engineer langsung, the operator bisa langsung lihat, what should I do? The business decision maker can straight away, I need to choose option 1 or option 2. Now, even in option 1 or option 2, the machine already tell us what is the benefit, how will it help? And then it's up to us as the final decision maker to make the decision based on the insight dari machine learning or profile of the machine. So I'm just using the machine as an example because that's what I'm used to. I'm used to industrial hardware guy. So you can do the same profile of anything else. So for example, this is prescriptive. So how the machine learning algorithm was running on how many years? Ini 15 tahun machine learning of data. It had access to this much data. So the more data you have, the more closer to accuracy you can have your model. And then this one also tarik dari 125 turbine yang same as itself. yang all around the world, tapi dia bisa all of the operation dia bisa ambil semua and bikin this is the proper operating profile of a D11 steam turbine. And then it already ran like hampir 60 ribu simulation runs to try and find the best solution for you. And because it has all of that data, it has all of the years, it has so many sources of information, because each of the steam turbine, dia ada IoT-nya udah lengkap. And then the machine learning will work on the historical data. So it even tell you, I'm 95% sure that this is the best way to do it, but so please just pick option 2. Otherwise, if you don't, I'm gonna cost you $12 million to fix that. So this is where the finance people, orang finance in the company, they're interested only in numbers. So if I can save 40% less fuel, yeah, I would do that. And if I don't want to have unplanned outage, if I have to replace satu turbine, which costs $12 million, I will fix it before it will break. So with the all of these systems together, it's all about data acquisition, data processing, and data generated insight. So from the machine learning gives you the insight. And why the insight? So you can make better decisions in your company. And then this is where just a rough, I found this, where there's so many different places that machine learning is being used. All of these companies are using one form of machine learning or AI. Of course, the high level is called AI, but inside is all the different algorithms for machine learning. So you have image processing and all of that. So this is, again, for the finance people and for the how big the market is for this. How much is my machine learning system worth? Why should I do machine learning? Why should I deploy IoT? You need to look at the angka-angka and the opportunity yang di depan muka. So for example, the maintenance services here, ini I just took from Garuda Airlines annual general report. And then they said they have, like, for example, 2018, ada 411,000 incidents, so opportunities of for collecting data. So each one of these, I can collect data at line maintenance, at the airframe, at the component, at the engine. All of this is data that I can use in my machine learning to look after my business. So for the engine, I collect all the engines information for machine learning for the turbine of the pesawat. And then if you look at all of this, how much money was it worth? This is like USD 212. What's that? $212 million. It's a big, it's a big, what do you call it? If you can save 1% of that or 2% of that because of your machine learning optimization, why not? That is how you can implement some IoT systems, some machine learning systems in the industry, because soalnya kadang-kadang they nggak mau keluarin duit, tapi you have to be lebih pintar. Say, oh, how much are you wasting on maintenance, Bob? So if I implement this system, I can kurangin your maintenance budget outlay by this much, and then you prove with this system machine AI. IoT. Put the IoT in, acquire the data, and then you do your machine learning profile, and then you give the insight for the. So now I'm gonna go back to IoT basic stuff. So this is back to zero. So data basics IoT. How do we see, kan kita orang, how do we perceive the world? We have our 5 senses. This is an example on the picture. You see the microphone for your kuping, CCD for your eyes, gas detector for your nose, a pH value, EC for your tongue and taste, and buttons for your fingers. Now, this is how, yeah, then I'll show. Soalnya, what does the data look like? The data in the world is analog. If you look at the sine wave, even if you look at the matahari malam, it's all analog. It slowly goes bright day, and then it slowly goes night. Imagine if it's just on day and off night. It's like shock to the system. It's the world is analog, but computers, machine learning, all these chips, they need digital. They only understand digital. They only understand 10, 10, 10. So we have to convert it from the analog to the digital. So if you look, for example, these digital waves ada dua di sini, the first one is representing the letter S. Huruf S is this one. This is what it looks like in digital. Huruf F is, this is what it looks like. The ASCII letter F, this is what it looks like. This is what the computer sees it as at the lowest level. So IoT, it creates data. As I said, this one here is a wave glider. It's an IoT platform for the sea. So why I give you information tentang sea all the time, because I was a marine engineer and I want to share with you what I see, what I touch, and so I can explain more about it for you. So this is liquid robotics. Ini like a drone untuk in the sea. You just let it go. Dia nggak ada motor. Dia pakai tenaga ombak untuk jalan. So if you click on the QR code, you can find more information about this. And then the platform ini, kita bisa pasang sensor apa aja. So we can, for this one, kita pasang sensor hydrophone untuk tracking ikan paus, whale. So when the whale is moving, we can listen to them. And also to tracking kapal selam. So this one, kita bisa record the sound. So attributes of IoT, dia collect data. Now dia harus store the data. Where are you going to store the data? On that very old, anybody remember this? This is like a 8-inch floppy disk. Now the capacity of this is 80 kilobytes. 80 kilobytes. Yeah, you can see on the screen. 80 kilobytes. I found this and I'm keeping it. It's a bit of history, you know. We can't use it anymore, but this is where we came from, where computer system came from, storage. Anyway, continue. So we can see that the data is represented in bits, bytes, kilobytes, megabytes. You know, everybody knows that. Data storage types. These are the electronic components that store the data. Transistor, EEPROM, floppy disk, hard disk, SSD, NAS, SAN, data lake. So, and you have the cloud. The cloud, when people say the cloud, it's actually one building full of SSDs. So it's still hardware at the bottom, but it's just somewhere else, not physically at your location. Now we have the communication. IoT collect the data from the sensor. It will transmit the data to the server, because when ikan itu bisa di jauh-jauh. So imagine this sensor is in the middle of the sea. How is it sending data to me? It's sending the data via satellite and VHF. So when a kapal terbang goes over, it can ambil the data and then fly away. So here we have the different IoT, different data transmission protocols available for IoT. IoT, I don't really like the name. It should be an embedded system with an internet connection. That's for me. So we have a different kind of transmission rate. So if you can see here, the L3 modem, ini yang modem yang dipakai di dalam the project for James Cameron yang paling dalam dasar laut. So when in the kantor, I was carrying the two modems, backup and primary, on my pundak, on my shoulders, and say, hey, this will take James Cameron to the bottom of the sea, yay. Tapi sayangnya I didn't take a photo. Like, that's very bad. Anyway, that's what happens. And then the format of the data. So how the sensor record the data and then this gets stored in the data, itu bentuknya apa? So ada text, ada CSV, ada Excel, ada audio, ada video, ada photo, and some sensor ada proprietary format sendiri, so dia nggak terbuka. And then it will transfer the data by time series, batch, and real time. So normally IoT is real time. So imagine kan tadi I looking at the turbine. Itu sensornya udah ditempel, udah ditanam di dalam mesin itu. Nah, itu secara real time, secara sekarang, this instant, this second, itu akan kirim data ke machine learning profile. So dia machine learning profile selalu jalan, selalu monitoring terus. So this is some definitions, some more theory stuff. Industrial IoT, Internet of Everything, Internet of Things. It's just another word. Yeah, so don't get too confused about, wow, what is it? It's just embedded chip with the internet connection. It's just something connected to the internet. That's all. Yeah, okay, I said it for myself. It's just another way to acquire data. Data for business processes, machine learning, to make data decision trees from inside. Soalnya, to do it is in the decision. You spend money because of a decision. You make money because of decision. And how you make a decision? Because you have data, you have an insight, because the machine learning profile told you something. This is what more or less the same thing what I just said. IoT collect any data for analysis and processing. It feeds into the machine learning profile algorithm. The algorithm using the correct algorithm for the training profile, and the profile insights to make decision, do action, and then hopefully we make some money. This is just like a time series data example. This is a temperature, a lembab, some temperature sensor. So you can see the temperature is underneath like 9 degrees, and the humidity berapa percent is like 30%. So in the machine, if you look at this, so from a machine learning point of view, this can be the normal operating temperature and of a machine. And then if you see the 20 degrees and the 10 degrees, I mean below at the two limits there, the low alarm and the high alarm, itu is a soft limit yang bisa dibuat for you by the machine learning. Soalnya the machine learning udah ada profile mesin ini. Mesin ini bisa paling panas and paling dingin gitu. And then the machine learning per unit akan beda sih, beda soalnya secara mechanical beda. And then it will automatically tune these alarm for that sensor, for that machine, sorry. So that is the application of machine learning. I know it's very simple, but I just want to try to make as much people understand what is machine learning. So here is some complex data. It is time series data. So this is data from the sonar. So I use the sonar to do the mapping of the under the sea. And then if you click on this, it will show you the data about the source of this data. So I did this as a project for the Australian Navy. I look after the sonars for the ship, for the whole fleet. And so these numbers, each point is one GPS point, X, Y, Z, the height, length, X in 3D space, and accurate positioning. So this is GIS data. So any GIS guys there, this is your reference. So this is what it looks like when you put all of those text together and you put it into the viewing program. This is what it looks like. Ini udah clean. This is already a clean data set. Sebelumnya, we have to run algorithms to clean out all of the fish. Kan ada ikan, ada bubble. We need to clean all of that from the data. So this is, after cleaning the data, this is what we can see. So ini ada satu kapal RMS mungkin UK, Royal Merchant Ship Quetta, dia 1890 on top of Australia, dia kena batu in the ship, and then fell down. And then you can see the paling di depan ada seperti crack. So that's the crack where it hit the reef and fell down. Nah di belakangnya kan lihat, you can see ada lubang. So that lubang is ada diver, they salvage the mesin. Why they salvage the mesin? Soalnya mesin itu besinya itu di casting sebelum era atomic. Why? Why is that important? Sebelum era atomic. Sebelum the atomic bomb meledak, pas meledak, atomic bomb meledak, semua everything got contaminated by radiation. Nah, besi di dalam mesin ini itu udah satu pack sebelum the atomic bomb. So it is very rare metal yang dipakai untuk di dalam radiation detector. So because dia nggak emitting radiasi sendiri. So this is again back to my previous life, but I'm trying to see that the application of IoT, the sonar is a sensor. It is collecting the data, so much data. In 10 minutes, I can collect one GB. And then we see some applied IoT. So LiDAR, dia pakai laser untuk bikin gambar. Sonar, I just explained pakai suara. Spectral itu the different wavelengths of light. So kan you lihat ada pelangi or rainbow, itu kan cahaya udah dipecah ke the different wavelengths. So that's a spectral. Ada kamera yang bisa baca just the different wavelength of the thing. And then I just put the thing for local GPS for Jakarta. So I'll show you some use cases. This again, I'm just showing off now. I built the robots and we came fourth place. You know, fourth place, $0 USD prize money. If we came first prize, it's 750,000 USD. Well, anyway, that's just the experience. So these ones, they use the machine learning in the object recognition for the in the image processing, and also for the mapping, using the LiDAR to map the whole area, and then they share the map to everybody, so then they can know which way to go. And then also how fast the motion to drive the robot, that is also controlled, but from within itself because of the boundary of the profile that's already been programmed by the programmer. And this is what it looks like, the dataset dari LiDAR. Ini pakai gambar 3D di dalam ruang pakai LiDAR. So I made this. I just walk around, jalan, and then do it. So imagine if you get this data, and then you bisa bikin seperti AR, atau bisa bikin game. So this can become one of my games maps. I can turn my house into a map for my game, for my, I don't know, whatever famous games out there, Call of Duty or League of Legends or, you know, PUBG, whatever. So here we go back to sonar again. So all of these kapal, I went on them and I fixed the systems on them. So at the bottom, the submarine, the one up the top there is HMAS Pluma. So this is how the sonar works. The other satu, like a sound, and it goes down and it comes back up. And then from that, it makes a picture, because it's not just one microphone. Ada di satu sonar, kepala sonar, ada 880 mini microphone. So tiap kali ada satu rak, satu suara, ada 800 data point yang masuk ke sistem kita. So that's a data acquisition. And then we have to do the machine learning on that. So to make the gambar, to clean the noise of the fish and any other like plants. And also we use the hasil from the sonar is bikin peta laut. So orang yang ada kapal bisa navigasi seperti the Google map of the sea. Yeah, that's what the sonar is for. And then ini yang spektral yang saya bilang NDVI. So we can use a camera yang ada NDVI camera di drone di lahan-lahan petani, and kita bisa nge-scan lahan mereka, and then we can see how the crop is healthy or not. Kalau ada hama, kalau ada kok ini lagi ada something happening here. So dia bisa lihat ke sana and then lihat, oh ini kurang air, or ada some insect, or not enough, or too much pesticide, too much fertilizer gitu. So kita pakai tools ini, sensors ini to make a decision, so we can live, we can make money, we can do something. And this is again what I said, using the drones not these drones. These are drones I made by myself. They didn't use in this project. The first other picture I used that one. So you can see the sonar data and the photogrammetry data. So two data sets, two different data sets, we put it together, and then to make the product for the customer. The customer in this case was ASN, Alcatel Submarine Networks. So ini ada the landing point in Hawaii. So ini di Hawaii. Dari Hawaii, the kabel fiber ke Tonga, ke Fiji, ke New Zealand, di atas New Zealand, dari New Zealand ke bawah New Zealand, and then dari New Zealand ke Sydney. Itu 14,000 kilometer. So that one cable to increase the bandwidth of your internet. So that's what I. And then, so I got some data from Transjakarta. So this is their peta in 2015. That was their service when they baru pasang GPS di on the bus. So dia bisa lihat ini sebenarnya coverage kita di DKI, di DKI ini seluas mana sih? And then kita bisa lihat ini masih ada banyak yang kosong, masih banyak yang bolong gitu. So sebelumnya dia nggak ada data, nah pasang GPS, IoT sensor, dia dapat data. Habis itu kalau lama-lama mungkin 10 tahun atau yang paling minim untuk machine learning is 3 bulan. 3 bulan data, baru kita bisa dapat insight yang berguna. So maybe after 3 months, they can manage the route or bikin more, just monitor the fleet of the bus. So even using that the GPS and the speed sensor, they udah bisa lihat impact of ganjil genap on their services. So if you see some areas, the busnya bisa lebih cepat because of ganjil genap. In some other areas, it's no effect. In some other areas, it's malah turun. But most of all, it's naik because the bus can go faster from halte to halte because of the ganjil genap. So with the possible machine learning insights that they can use for the profile, they can profile each bus. They can make a machine learning profile per each driver. Drivernya gimana? Atau dia suka ngebut atau ngebut, yeah, go too fast. And they can see the profile per person and per driver and per route. So they can say, oh, we need more buses. Or we can say, hey, this driver is going too fast all the time and he's using my petrol too much. So we have to say, hey, can you please slow down or be more careful? So it's the machine learning for business impact, for business decision and optimization. For example, this is one little startup, Indonesian startup. Yes, I was the technical advisor and I helped them in the hardware they bikin alat untuk ukur the pressure, tenaga, the water pressure in the PDAM. So ini udah di 5 titik di Jakarta udah dipasang. So the PDAM bisa memonitor the pressure, the water pressure, so they can see, okay, I need to do capacity building, or this one is always lemah, this area. So they only install this system tahun 2018. So sebelum 2018 itu semua secara manual. Ada orang harus go there and baca the meter yang mundur and like catat, habis itu jalan lagi. So that data collection is so slow that they are losing money and the customer service is not very good. Nah kalau ada sistem ini IoT, customer service mereka bisa naik. Dia bisa bikin, oh kita perlu, we need more pipa di sini, harus lebih besar density-nya, harus lebih banyak pompa di sini. So they can pas Jakarta lebih bangun and more people, they can adjust their capacity. So then they can make a machine learning profile per area, per RT RW, per city, and then they can see that, okay, in musim hujan, or begini, or musim panas, or begini. So that's what we need the impact, because they have to spend money, right? So if you can manage how you spend your money by having good information, why not? So, and then this is back again to me and to the talk a lot about me, far out. So Zulu and Gojek, kita kerja sama dengan Gojek, and then this is more in detail. So we have every single helmet, jacket, and gopher bag ada RFID tag. So the RFID tag untuk tracking inventory mereka. Soalnya sebelum ini they always have problem inventory-nya hilang. So kita instalasi seperti IoT system untuk scanning data per jacket helmet, and then itu langsung bisa masukin ke sistem ERP, SAP mereka. So, for example, kenapa we have to put digital? Ini namanya digital transformation. So, if you hear what the name digital transformation, itu berarti ada implementasi IoT, ada implementasi data processing, machine learning, anything, and then ada outputnya di dashboard atau untuk C-levelnya bisa bikin some decisions. So, ini tiap 4 bulan dia rugi $24,000 US. So they lost so much sebelum sistem ini di install. And then untuk dari truck masukin ke gudang mereka untuk inbound item, itu dia harus bongkar satu dus and then hitung manually. So itu 5 sampai 10 menit. Nah kalau kita deliver 8,000 jaket sehari, itu nggak mungkin dia manual ini. So this is where we help them in the digital transformation. Kita di antara pabrik sama gudang mereka pakai RFID. Nah, abis itu kita pasang QR code juga, soalnya alat-alat RFID terlalu mahal. So untuk di daerah-daerah, so kita pasang QR code, dia bisa pakai aplikasi sendiri yang dia rakit, and then dia bisa inbound, outbound jacket helmet mereka. Sebelum ini, it's all manual, pakai Google Sheet, clipboard di kertas, Google Sheet, itu Google Sheet ke SAP. So dengan ini pakai sistem ini dia bisa langsung jual ke driver secara langsung. And then of course we did the innovation of making these IoT devices untuk pabrik. So untuk support this project. Kalau tanpa sistem ini kita sama aja bohong. They will be losing inventory. It will just be like the old way. Dia harus hitung secara manual. Nah, gila kalau lihat aja delivery ke gudang mereka 12,000 helm per hari. It's insane. So we made the machine. It scans the RFID yang udah di dalam and give the QR code. So ini the insight. Ini why, kenapa. So later, what I can do with machine learning is aku dari sisi Zulu, aku bisa lihat masing-masing pabrik, and I can give a profile per pabrik, per effective operation hours, cost, and output. So then itu bisa bikin lebih gampang untuk order-order yang the next order. Saya bisa pilih yang pabrik yang paling bagus di antara semuanya. Soalnya kita nggak mungkin pakai satu pabrik untuk ini. Yang di 6 bulan kita harus deliver 1,2 juta jaket, itu kita pakai sampai 8 pabrik. Nah, satu pabrik ada hampir 1,000 orang di dalamnya. So, if you can imagine that kind of operational data that is coming in, we need a digital system, IoT, to collect the data. And kalau ada banyak data, kita bisa olah data untuk cari yang optimum. So ini kenapa sih? Why do I do the machine learning insights? Why? So I can see for my alat, I can monitor my machine juga. So dari Zulu bisa memonitor IoT system saya sendiri, bisa monitoring the pabrik juga capacity. And then kalau preventative maintenance, kalau itu mesin rusak, itu satu line stop. Nah, saya rugi kalau itu satu line stop. So I need to always know if that machine is jalan terus. Kan lumayan, delivery 8.000 jaket per hari. So crazy. So anyway, enough about me. Now it's your turn. Now, this is my favorite part. I like to say, hey guys, it's your turn to. I already give you so much knowledge, so much information, so much sharing. So now, what can you guys do? So what can you do? So think about, 5 possible machine learning insights that will benefit Indonesia using the data from Indonesia. Kalau perlu IoT system, what kind of data do you need? And then using what kind of machine learning algorithms to help Indonesia. I mean, an idea is just an idea, kan? So if you want, just lihat aja di samping kiri, samping kanan. Not now, kan, dulu in the classroom ini bisa. You just look in your neighbor, kan? Soalnya dari your faculty masing-masing, kita harus kerjasama. Soalnya nggak mungkin satu orang rakit satu sistem. There's no way. Ini harus kolaboratif. So if the anak elektro, dia bikin satu alat IoT, nah dia perlu anak bisnis sama anak marketing untuk jualan itu, kan. And then orang bisnis untuk bikin business model. Oh, ini laku nggak? Ini perlu banget nggak? So you have the market research orang, and then you have the accounting, finance people. So pas duit masuk, ini direkam semua, So if you have the idea and then make it big. Soalnya, like for example, ini ada satu cerita saya dari kan aku tinggal di Australia, aku bolak-balik. Nah, tahun 2000 aku ke kampung saya di Polowali. Nah, di sana ada tante saya, dia ada panti asuhan. So pas saya ke sana ada anak satu namanya Akbar. Nah, Akbar dia menjadi tour guide saya. Saya naik bawa mobil, dia, sini sana Pak. Bang, bukan Pak. And then habis itu saya ke sana lagi tahun 2005. Saya said, ini mana Akbar? Oh, Akbar udah di Jepang, Pak. Bukan Pak, Yusuf. What's he doing in Japan? I said, dia lagi working in the Mitsubishi factory. I'm like, how can this anak yatim in panti asuhan in the middle of nowhere end up there? So ini apa namanya? It's like bikin inspiration banget. Kalau saya udah ada so many facility, kok saya not do something, kok saya just complain dulu. I need to do something juga. So that's why I'm here today. I have some experience yang aku mau sharing sama kalian, and I hope you get some better idea of what is machine learning. I know not in the analytical and the how to do it, tapi dari high level, and where does IoT help it. So we have the acquisition, kita harus kumpulin data dulu, habis itu kita olah pakai machine learning, habis itu kita bisa keluarin decision. So thank you for your time. So it's like ask yourself, like tanya diri sendiri, just for the students, right? What do I want to be? I know kadang-kadang kita nggak tahu kita mau nggak. What do we want to be? What do I want to be? I don't know. Ya kadang-kadang di dalam diri sendiri, it is something, kita ada interest, tapi kita udah lupa interest itu apa. Soalnya kita bisa pakai interest itu untuk menjadi motivasi besar kita untuk berjuang di karier kita masing-masing. So if you look at that peta yang dunia itu yang tempat yang saya udah ke sana. I went to New Zealand, Papua New Guinea. Aku hampir bunuh di Papua New Guinea sama tribe di sana. Dia kira saya lagi lagi stealing their fish, ikan. Saya lagi nangkap ikannya, tapi enggak. So pas saya di situ, aku lagi ada alat mesin untuk ukur salinity air. So, saya taruh di bawah, nah aku tarik naik ke atas. Pas aku balik, ada 5 orang warrior yang ada parang gede. Dia lagi nengokin aku lagi nih. Wah, aku nggak dengar dia. Dia naik kapal saya nggak dengar. It's like, oh my God, what did you do? How did you do? And then they scared me. So, apa namanya? Then that kind of shocked me. So like, it doesn't matter. Just try. Kalau ada idea kecil, just coba aja. And then who knows where you will be? Who knows where you will end up? Tapi kita harus coba. Kalau kita nggak berjuang, ya, how will we get anywhere? Yeah. And then, yeah. So your idea, cari teman untuk kolaborasi, and then make sure the business model is good, and then bisa bantu siapa, and then the impact on in Indonesia, and how can you bring Indonesia lebih tinggi. So ya kan kita di dunia ini, our time is udah getting shorter. So if we know that, kita bisa kasih waktu kita untuk any good cause, Yeah. There's one thing I just want to share, one last thing. I have a grand uncle di Sulawesi, so so he was fighting the Belanda. Sorry, he was fighting the Belanda, and then after that, he fight the Japanese, and then the orang Japanese, dia capture my grand uncle and put him in the penjara, and then he told the the other prisoners, said, sorry, hey, kita harus lari dari sini, and then they just ran out the front door, and then lagi ditembak sama Japanese. So sorry, just give me a second. And then his life, I always see him, he's always berjuang. So dia menjadi bupati in Sulawesi, and then berapa kali, and then pas dia udah pensiunan, dia suka ke pasar-pasar gitu, and then he will find the anak-anak yang not doing any job and say, hey, sini, and then dia ke lahannya dia, and then dikasih ini 1 hektar untuk you do your stuff. So dia kasih so the people, he give the people livelihood, he give the people job. So sorry. Yeah, I just hope I got inspired from that, so I cannot complain melulu. So yeah. Anyway, that's my show. Hopefully it's berguna, and thank you for your time. And I'm back to you guys so much. Thank you. Wassalamu'alaikum wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Actually, this is very, very amazing. Share. As you also talk about and share your family, your experience a lot. Yeah, maybe from all audience have a question.
Yeah, boleh.
Yusuf said.
Yes, 100%.
Yeah. Actually, we have a time up to 12 o'clock. Is it right? Yeah, Mr. Yusuf? Yeah, okay.
Yep. Silahkan.
Bapak, Ibu, silakan, atau adik-adik semuanya. And our chat meeting, actually, we got a question, Mr. Yusuf.
Oh, so I should just stop sharing my screen, huh?
Yeah, from Pak Zainul. Halo, Pak Zainul.
Let me see.
Pak Zainul?
Iya.
Pak Zainul mau sampaikan ke Mr. Yusuf?
Oke.
Ya, time and place for you. Oke.
Mr. Yusuf, thank you you perspective of artificial intelligence. I use
Bisa
Indonesian
pakai
language.
bahasa, bisa pakai bahasa. Saya bisa mengerti, tapi keluarnya agak susah. Tapi ya silakan kalau bahasa lebih gampang Ki.
Oke, terima kasih. Pertanyaan yang pertama dari saya, Mr. Yusuf, apa perbedaan yang paling mendasar? Jadi paling mendasar antara deep learning dan machine learning. Yang kedua, kapan saatnya saya menggunakan deep learning atau machine learning?
Yeah.
Yang ketiga,
Okay.
kombinasi model aktivasi dalam hidden layer pada mesin dan machine learning atau deep learning yang paling efektif, caranya bagaimana?
Wow. These are really deep questions. I'm not the machine learning expert, but I'll try to any.
Okay, thank you, Mr.
So ini Pak Aram, ini between the two, like what you said, the machine learning and the deep learning, it is tergantung on the amount of data and the amount of decisions have to be made. So, for example, the deep learning, you cannot use a normal computer to do the computationals. It's too much. That's why you have the NVIDIA Jetson chipsets, and you have the NVIDIA GPUs to help you to do that. Now, for the difference between machine learning is machine learning, and it's under the same umbrella. It's just that deep learning is using more data and more how do I say this? More. All right. You got me.
Yeah.
But it's machine learning and deep learning is the same thing. It's just under the different family. It's just application of how you implement deep AI is a totally different. It's like you need so much more expensive machine, so much more computational power compared to just a basic machine learning that just says, okay, my temperature should be this and my temperature should be that. Whereas if you want to do like deep learning, that's like you're going through so many computational, so many. For example, you're playing the game chess or Go, that's where the deep learning is, because it has to count for every single movement. It has to calculate that and the probability, and it has to take all of that into account. Now, I'm not machine learning expert, but that's as best as I could answer you on your question.
Okay.
But if you want to use the deep learning, it's for example, the deep learning, it would be for like you're doing genetics, gene therapy. You need to break down the gene structure, or you need to play a game. You want to beat somebody at a different game. It's an application that has so many different kinds of outcomes, and you want to find the best outcome for you. Whereas just a normal basic machine learning, just to give me, okay, the operation of this AC harus between this, this engine or this truck harus between this level. It's just monitoring. A simple computer can do it. Whereas with a deep learning, I have so many things happening at the same time that the hardware has to be able to reflect all of that computation at the same time. For example, if you're doing the chess moves and you want to analyze the chessboard at once, you have so many pieces, and a normal computer cannot do that. Cannot, like for example, Arduino cannot analyze all of that at once. It can, but it will go very, very slowly because the clock speed is very slow. Whereas with the deep learning, you're using like a supercomputer. The clock speed is so fast, the memory is so fast that you have so many transistors to. Aku lagi talking from a hardware perspective, kan? Because I'm a hardware guy. How to implement it. So to be able to do calculation according to the algorithm to give the best fit for you. So I mean, to run a solution for that, to finish the game or whatever. But yeah, I mean that's the best thing I can give you for the answer for your question. Yeah.
Okay.
That was pretty tough one, man. Wow.
Okay. Yeah.
Okay.
Anyone next?
Yeah. Gimana Pak Zainul? It's okay?
Okay. Okay.
The
Thank
last
you.
one. The last one.
No, he got me very good.
Already answered from Mr. Yusuf. Talk about the model in hidden layer.
Oh, the hidden
Yeah.
layer? No,
Yeah.
Yeah.
that is too
Didn't
new
cover.
for me. I'm still new for that stuff.
Yeah. Must go to the research, I think. Yeah. Okay.
Nanti I'll find some material that I can share in the link when I share my slides, so I'll touch that for you.
Okay. Thanks. Pak Zainul cukup?
Oke, cukup. Thanks. Thank you.
Cukup. Oke. Yang lain Bapak Ibu partisipan, adik-adik, mahasiswa. Okay, maybe I think this is I think the confused explanation apa important thing, but maybe still round up and have maybe some information to get catch it. If no question, we can finish this event, Mr. Yusuf.
Yeah, boleh.
Thank you very much. And all audience, all participant, yeah. Alhamdulillah, actually, yeah, this event can already properly done. And then once more, we say Alhamdulillah, Morgan. We say also thank you very much to Mr. Yusuf talking about this topic today. And maybe sometime you can, and also I invite you to welcome to UIN and Ciputat, actually, yeah, because near BSD, yeah, okay. We close this event with the recital Alhamdulillahirabbil alamin.
Yes, thank you for having me. Thank you.
Okay.
Thank you.
Ya, Bapak Ibu, silakan.
Terima kasih. Thank you, Pak Yusuf.
Thank you.
Langsung ya. Langsung ke Pak Yusuf ya, ngeri ya. Dah keluar.
I see. That's what it is.
Masih sedikit. Sejak gejala pertama